Take a look at this exponential equation. 2 raised to x is equal to 9. Can you solve this by making the bases the same? The answer is no. This can be solved by exponential. So in order to solve this exponential equation, the concept of logarithm is needed. So if you are interested on how to solve this kind of exponential equation, continue watching this video. Hello everyone, welcome back to our math room. In this video, we are going to have another lesson in general mathematics, and the topic is all about solving exponential equations with different bases. So what is our learning objective? At the end of this lesson, you should be able to solve exponential equations with different bases. So how do we solve an exponential equation with different bases? First, isolate the exponential part of the equation, and if there are two exponential parts, put one on each side of the equation. Next, take the logarithm or natural logarithm of both sides of the equation. Third, apply power property to rewrite the exponent. And fourth, solve for the value of the variable. Let us now have some examples. Find the value of x in the exponential equation with different bases. Looking at our first example, 2 raised to x is equal to 9. We cannot do anything with 2 and 9 to make them the same. Therefore, we need to apply the concept of logarithm. So we have to take the logarithm of both sides. So we have the logarithm of 2 raised to x is equal to the logarithm of 9. Next is to rewrite this using the power property to remove the exponent. So we have x logarithm of 2 equals the logarithm of 9. Divide both sides by logarithm of 2. So x is equal to the logarithm of 9 over the logarithm of 2. So if we're going to press our calculator to get the value of this is equivalent to 3.1699. You might be wondering, how about if we're going to apply the natural logarithm? So let's do it. So if we have the ln of 2 raised to x is equal to ln of 9, do the same procedure, rewrite this using the power property. So we have x ln of 2 is equal to ln of 9. Divide both sides by ln of 2. So we have x is equal to the ln of 9 over the ln of 2. Press your calculator. Will you get 3.1699? The answer is yes. So whatever you will use, either the common logarithm or natural logarithm, you will reach the same answer. Second example, find the value of x in this exponential equation. E raised to x minus 1 is equal to 27. Since there is a presence of the Euler number, which is under the natural exponential, then it is a must for us to use the natural logarithm. So we have ln of e raised to x minus 1 is equal to ln of 27. Apply the power rule. So we have to remove the x minus 1 from the exponent. So we have x minus 1 ln of e equals ln of 27. Next is to distribute ln of e to these terms. So we have x ln of e minus ln of e equals ln of 27. Next thing to do, we have x ln of e, isolate this, equals ln of 27 plus ln of e. To remove ln of e, we need to divide both sides by ln of e so that we can only have x on the left side. So we now have x is equal to ln of 27 plus ln of e over ln of e. Pressing your calculator, you will get an answer of x, approximately 4.2958. So this is the value of x for this exponential equation. Third example, Find the value of x in the exponential equation 4 raised to 3x plus 1 minus 5 is equal to 10. To solve this kind of equation, we have to isolate the exponential expression. Therefore, the negative 5 has to be placed to the other side. So we now have 4 raised to 3x plus 1 is equal to 15. Next is to take the logarithm or ln of both sides. This time, let us use the common log. So we have the logarithm of 4 raised to 3x plus 1 equals the logarithm of 15. Next is to apply the law of a power. We have 3x plus 1 times the logarithm of 4 equals the logarithm of 15. Distribute or multiply logarithm of 4 to these two terms. We have 3x logarithm of 4 plus the logarithm of 4 equals the logarithm of 15. Next is to isolate the term with x. So we have 3x logarithm of 4 equals the logarithm of 15 minus the logarithm of 4. Solve for the value of x by dividing both sides with 3 log 4. So we cancel the logarithm of 4 and the 3. So we only have x equals the logarithm of 15 minus the logarithm of 4 over 3 logarithm of 4. Use your calculator to get the approximate value of this. So we have the approximate value of 0.3178. So here is the answer for this equation. Last example, find the value of x in this exponential equation. 5 raised to x minus 3 is equal to 3 raised to 2x plus 1. We need to take the logarithm of both sides. This time, let us use the natural logarithm. So we have ln of 5 raised to x minus 3 equals the ln of 3 raised to 2x plus 1. Next is to apply the law of a power. We have x minus 3 ln of 5 equals 2x plus 1 ln of 3. Next is to multiply the ln to the binomial. We have x ln of 5 minus 3 ln of 5. Do the same thing. Multiply ln of 3 to this. We have 2x ln of 3 plus ln of 3. Place all the terms with x on the left side and those without on the right side. So we have x ln of 5 minus 2x ln of 3 equals ln of 3 plus 3 ln of 5. Next is we need to factor out x as a common monomial value on this left side. So we have x times ln of 5 minus 2 ln of 3 equals ln of 3 plus 3 ln of 5. To solve for the value of x, we need to divide both sides by ln of 5 minus 2 ln of 3. Cancel this. We have x is equal to ln of 3 plus 3 ln of 5 over ln of 5 minus 2 ln of 3. Press your calculator to get the value of this. We have the approximate value of negative 10.0835. So this is the value of x in our given equation. After showing you how to solve exponential equation having different bases, it is now your turn to check your own understanding. You may pause the video to answer these items. Let's check your work. First one, the answer is 1.7565. And second, the answer is negative 0.0615. Did you get these answers? If yes, great job! Here are the important things that you need to take note in this lesson. To solve exponential equation with different bases, you need to isolate the exponential part of the equation, and if there are two exponential parts, put one on each side of the equation. Next is to take the logarithm, either the common or natural log of both sides of the equation. Third, apply the power property to rewrite the exponent. And last, solve for the value of the variable. Here is the end of our discussion about solving exponential equations with different bases. Please don't forget to subscribe, like, and comment on this video. Bye everyone! See you on our next video.